tells us we gotta multiply before we add. And so you're gonna do any of your stretches first, and then you're gonna move. So you wanna stretch before you move, kind of like that physical activity as well. So we're gonna do any stretches, compressions. Compressions are just a stretch that's a fraction, and reflections, because all of these things, all of those things, math-wise.
Good morning, everyone. My apologies for the late announcement. Just walking through the kids' class. So, as you're probably well aware, the cafeteria will not be open this week, but as soon as the door is open, you will be the first to know. Our students need to do some safety protocols prior to starting to cook. Students who are registered for lunchtime credit recovery need to check the whiteboard by the Trojan Gym. We're hoping for lunch activities to be up and running by Wednesday of this week, but just looking at the announcement, we will let you know. We have 3 Trojan athletic sports starting and continuing trials today, so please listen closely. If you have any questions, you need to see one of the teachers or coaches for more information.
Sorry,
we have women and girls soccer tryouts continuing today at 4 p.m. at the Birchwood Soccer Field. Any students who are unable to make Thursday's tryout must attend in order to have a chance at making the team. Please see Mr. Gallo, Ms. Jacoby, or Mr. Fairby if you're unable to attend today. Golf tryouts begin today at the Thompson Golf Course at 4 p.m. Today is the only tryout for the golf team, so all students should already have signed up outside of the Cadet office, and if you have not, please see Mr. Valentino before the end of today. Any students wanting to try out for both soccer and golf must come and see the coaches before 3:30 today in order to ensure a potential spot on both teams. Volleyball gets underway today as well, with all 4 teams beginning their tryouts. Remember that only grade 9 and 10 students can try out for junior varsity, but all grades are welcome to try out for senior varsity. The junior and senior girls will have a combined tryout today at 5:15, and the junior and senior boys will have a combined tryout today at 6:30. All teams will have at least one additional tryout tomorrow, so if you're unable to attend the tryout, please see one of the coaches today. For girls, you can speak to Mr. Patterson, Ms. Monroe, or Ms. Keshmar, and for boys, you can speak to Mr. St. Clair. Good luck to all student athletes in their attempts to become a party partner Trojan. Next Monday, Life Touch will be here taking back to school photos, and all students will have their photos taken for our records, and then you'll have the option to purchase packages if you wish. The location of these photos will be shared later this week. That's all I have for you today. Lots of information. All of your teachers will have an email about this information if you need some clarification. So everyone have a fantastic Monday. Bye for now.
Hey, Miss Kelly, is this the same as grad photos?
No. Grad photos are completely different, and they happen during exam week in the first semester.
If you graduate.
Yeah, one probably wouldn't get paid for grad photos if you're not graduating, but
You have to pay for grad photos?
yep.
And then you're just gonna be in the whole party part for the rest of the training?
Yeah.
How long do the photos do you have on art parts?
I don't know, there's some up from 1984 or 82 is our first set of photos. Okay, I did a horrible job with coordinate pairs, so I made a table of values to make it better. So we're gonna go through doing a stretch, reflection, and a shift. So shift is gonna move it around the coordinate plane. Your stretches are gonna change the shape of your graph. So if this is the parent graph, if this is f of x, and this is the table of values that goes with it, because I screwed it up. This is given to you in function notation form. So I just want to stress to you that x isn't telling you the straight story when given in function notation form. If it's given as a mapping rule or in words, that's going to tell you the straight math. So if we go through this, we know that the 2 is telling us our y's are going to be multiplied by 2. This is going to be telling us that our x's, we're going to be adding 3. And our y's are going to be minusing 2. So if I make that a mapping rule, because the mapping rule is kind of nice because it just tells us what the math is that we're going to do. We're going to have x plus 3 and then 2y minus 2. So when that f is in there, that's in function notation. It's given in function notation, so it's not going to tell you the straight story. It's not going to tell you what it is that you want to do. So because I've given you the table of values, I'm going to use that to my advantage, and I'm going to do all that math to the x's and y's from this original table of values up here, just so we can see them before we plot them. Some of you are amazing in your visualization and you can do it no problem. Don't feel like you have to do a table of values. So the only thing happening in our mapping rule is the x's, we're adding 3 to them. So -2 plus 3 is going to be at 1, 2, 3. And notice that I don't have this point labeled. So I just got to pay attention. I'm like, these go up by a pattern here, but then I jump. So I got to add 3 to that, and that's at 5. It's just because I missed a point. I didn't need it because it's just a straight line. So just be wary of that. Like the points that you pick might not follow a pattern. So y's, we're going to multiply them by 2, and then we're going to subtract 2. So if I go here, 2 times 2 is 4. 4 minus 2, 2. Good job. Good mathing there.
Good job.
So this will be a 2 as well. And then the 1 times 2 is 2. 2 minus 2, those are going to be at zeros. So now we can go ahead and plot those points. Remember that your shape is going to change, like you're going to be stretched out a little bit. So it won't look exactly like it, but it should have the same general shape. So 1 and 2. So this endpoint, sorry, you can't see that. This endpoint here just translated to here. So this point becomes that point. So just keep that in mind, because we shifted 3 units to the right, so that would make sense. Ooh, and I'm off, so I'm there. I have a ruler somewhere. Oh, it's on my desk. Hey, do I put arrows on this graph? How come? How do we know that? And the parent graph doesn't have arrows. So we wouldn't put arrows on this graph.
Miss Downey, isn't it called the daughter graph?
We call it the transform graph. We don't give it a gender. Okay, are we all good with that one? Yes, sort of, kind of? And if you notice, like this has a, oh, sorry, you can't see what I'm pointing at. This one here has a height of 1, like it crosses 1 box. But here, it crosses 2 boxes now. And that's that height, that change, that vertical stretch by a factor of 2. She's on her way down. Yeah. Okay, bye-bye. All right, can you guys do the mapping rule for the next one? Can you guys do the mapping rule for the next one? Yeah?
Well, you can do it, Jonah. What did I do? I'm saying. Ew, that's a spider.
So again, don't use, why are you killing things with my ruler?
This is your rule, this is Jonas.
It's okay, that's fine.
Why are you littering?
So again, this one's not telling us the straight story. It's telling us 1/2, so we know our x's are multiplied by 2. This is timesing y's by -1, but what reflection will that result in? What axis will that reflect in? The x-axis. So if your y's are being multiplied by -1, that's going to be your mirror. Your x-axis is going to be your mirror. And you always go back to the original function to do your transformations off of. Yeah.
If you're doing this on, like, say, an assignment, do you have to label the graph that you're, like, changing?
Yeah, you probably could.
What do you mean? Label which one? This one?
Yeah.
If they're both on the same graph, then if I have more than one function on a graph, I have to label one f of x, and then I have to label the other one negative f 1/2 x. If they're on different graphs,
Yeah.
then you don't.
Okay. But if it's still, like, say, because we're going off that one, the parent graph,
Yep.
we still don't have to label it if it's on its own separate thing?
If it's on its own separate thing, you don't have to. Labeling the points you need just because that's what you're translating. So
Do dotted lines work for?
if it's a dashed line, then that's fine. If you put your If you have a dashed line, it's like an asymptote. It doesn't really exist, right? So, okay. So if I did my math right, that's what it should look like.
Hey, what's the point of this stretching stuff?
Pardon?
Oh, you did not just do that.
What's the point of this question?
The stretching.
The stretching. These transformations, just like you need to know how each number affects the graph, because all the types of functions we're going to do this year will be based on this. So it's really important that we get this down. Okay, why are you guys telling each other to shut up? Nobody's saying
I was
anything.
telling Jonas to shut up. Then I sounded right. Yeah. We put on the remote.
So again, what we're seeing now is not a change in height, we're seeing a change in that horizontal stretch. You should be able to tell that this graph is going to be wider because of this, and this graph will be taller because of this too. Okay, order of operations. It's very important. Are we good? Can I flip the page?
Yes.
Beautiful. All right. Okay. So with everything, you guys have to figure out an equation. We did these a million times. You had to create equations for given graphs. Now I'm asking you to identify the transformations of a given graph. Okay, one thing I didn't do on this was I didn't identify which was the parent and which was the transformed. So I'm going to say this big wide one is the parent. Okay. So I apologize. My dots should be like right up here. It was hard to label dots on my graph when I was doing it. So if dots are given on the parent graph, and then you see those dots on the transformed graph, that means those points actually transformed to, like, these points ended up here, and that point ended up there, okay? Oh, okay. So we're gonna deal with our stretches first, and we're gonna deal with it between those two dots. Let's deal with our horizontal stretch. So A represents our vertical stretch. B is our horizontal stretch. And when we put it into when we put it into the function notation, what do we have to remember? We got to use the reciprocal. C is your horizontal shift. And D is your vertical shift. Okay, so always deal with your stretches first. And stretches and reflections. Did this get reflected?
Yes.
No.
No.
No. If it was a reflection in the x-axis, we'd see it pointing down. This one's hard to see if we have a reflection because this is an absolute graph and it's symmetrical about the y-axis. So there might have been one, but if it's not obvious, don't put it. Okay, horizontal stretch. Look, I forgot a word. Hope you guys filled it in. We're going to look at this one. How far apart are these two dots? 8. Okay. How far apart are these two dots? 2. So what do I have to multiply 8 by to get it to 2?
4.
1 4. Okay, because if this is our parent and we're going to here, we know that our horizontal stretch by a factor of 1/4. So what's our B value? B equals 4. Right? So you just got to be careful with your horizontal stretches and shifts, just because those ones we have to kind of do the opposite on. So now let's do the vertical stretch. So we're going to look at the height in between. I'm going to take this point here. What's the height between these two? 4. And then what's the height between those two?
10.
Hopefully it's 8.
10 would. 10, what was you saying?
Oh, wait, yeah, 10. I mean, 8.
Okay, but those are easy mistakes to make, right? Like if you're rushing through it, you see where it is on the, you didn't notice that the bottom shifted up as well. So A is equal to how much? Not 8. What do I have to multiply 4 by to get it to 8? 2. So A has a value of 2. Okay, now we're going to talk shifts. What I want you to do is I want you to find a place on the original graph where x is equal to 0. So find on f of x where x is equal to 0. And hopefully I give you a nice easy one. It's right there at the bottom. So now if x is 0, where did you move to? Where did this point move to?
-7.
Negative 7. So we know that we went 7 left. So what's our C value? So it's going to be -7, but when you put it in here, it's going to be subtract a -7. So that's where it becomes the add. Why did I pick x equals 0 on the original graph?
So we don't need any math.
It is simple, but there's a more reason. Steve, we're going to find some kindness inside of you.
Are we?
Yes. It might kill me, but we're going to try. The reason why I picked x equals 0 is that the stretch won't affect this point. Any horizontal stretch will not affect this point because 0 times by 4 or 1/4 is still 0. So the stretch doesn't affect it. So when you go to do your vertical shift, you're going to find a point on the f of x graph where y is equal to 0. Because the stretch, the vertical stretch won't affect that point. Yeah.
For the -7, does the negative and the c like affect how it should be?
Yes, because that would be written as x minus -7,
Yeah.
which would then become +7. Right? Okay, what's my vertical shift? 2 up. So my d is equal to 2. Now we're going to put that all in function notation. So I'm just going to write it right on the graph. Y equals 2f bracket 4 bracket x plus 7 plus 2. Okay, you guys do the next one on your own.
We see you moving the desk dry, not slip.
What? Who's moving the desk?
You. I can hear it.
I can see your knee pressed on.
Okay, so try that one on your own.
Let's try it together, Dion.
Oh,
Not talking to you.
Is there a reflection in this one?
unfortunately, yes.
Yes. It's a reflection in the, it was up, now it's opening down. So it's a
Why?
reflection in the x-axis. So it's multiplied by your y's, right?
So we'll put the negative.
I just said that.
Yeah, I was talking to Joe on the boat,
Okay,
but he said it off.
perfect.
I think we'll just have to wait for it to unfreeze.
Remember, deal with your stretches first.
I'm doing this. He's got it. Where is he going?
Okay, so this one's good. This one's good. Negative one, negative one. Bottom part, got -4, no, 3, -4.
Shut up.
Just a point back there.
Find some kindness in the heart.
No. You shut up too, Kyle.
Okay, Steve?
Yo, Steven, how about I teach you a lesson?
Teach me a lesson.
Okay,
Alright.
gentlemen.
Teach me.
Gentlemen, I'd hate on day 3 to have to ask somebody to leave. We've made it this far together, we're gonna make it the rest of the way.
Or how about just with or without Steven?
Whoa. Mm-hmm. Nope, just wait till we're done. Wait till everybody's had a chance. If you want to come up and look at mine, you're more than welcome to, Rahat.
Bruh, am I high or something?
Yep. Hey, you hit my desk.
Activate them. Like, I think I see you do it again.
What happened?
Oh my god.
Do you guys want to see the answer or are you still working?
We're ready.
We're ready.
How about the rest of you? Yes, ready, not ready?
If Jonah's ready, we're all ready.
All right.
Not
No, that was an insult. Yeah, he's not ready.
Oh, that was an insult.
Yes, Jonah. Oh, check. You did it good. You did it good. Yeah. Eat up for hot. Look at that. Look at that.
So this one is really important. Ladies and gentlemen, sorry to interrupt. It's really important that when you are doing your horizontal and vertical shifts, you're finding where x is equal to 0 on the original one, because the reflection won't affect it. Like, so for this one, 0, my vertex 0, 0, I knew that the vertical shift of -3 times 0 is still 0. So the only thing that would be applied is the shift 4 units down. So that's why it's really important to find those coordinates that are going to be helpful. Well, because it was 2, sorry, on the original graph it was 2. And on this one it's 4. So I know I have to multiply by a factor of 2. And we know that the b values, or anything with the x, we know that we have to do the reciprocal of it.
Oh, so x is always,
Yes.
always opposite to x.
Kind of, yeah. Yeah, it was the same thing in, this is parabolas, guys. You did these last year. Yeah.
Where did they?
The equation for it? Oh, for this one, sorry.
Wait, Miss Kelly, which one's the original graph?
F of x.
How did you get -3?
I want you to read all my lines that I have there.
Never mind.
Right? I know the a value has to be negative because there's a reflection in the x-axis. If there was a reflection in the y-axis, then my b would have to be negative. Okay. Okay. How did I get what number? The number 3? Okay, so what's the height of this graph? I just went, the distance between the vertex and that point was a height of 1. And then if I go to the transformed graph, remember that these points transform to here. So my vertex to the transform points are now a height of 3. So what did I have to multiply 1 by to get it to 3? I multiplied by 3. Okay. This one is a trick question. The last example is a trick question. And the reason why it's a trick question is because you're missing a set of brackets. You're missing your innermost set of brackets. We've done this one before. You've seen it all before. So what we have to do is we common factor with that -2. Now, this is a very different conversation. This isn't going forward left, it's going to right. You must have, if there is a coefficient on that x, there has to be a second set of brackets, so you got to common factor it out. This is super fun for us to put on tests and quizzes, and I've also seen it show up on an exam as well. So just remember that if there is a coefficient on front of that x, you must use the double set of brackets. You got to common factor that one out. Okay, so what are the coordinates of the transformed point? Well, that's the apparent graph, therefore 3. So what's the mapping rule? It might be better if we do a mapping rule on this one. So my x's, what am I multiplying my x's by? Negative 1/2. And then what am I adding or subtracting to the x's? Plus 2. And then y's, what am I going to do to it?
Minus -3.
Times by -3. And I'm going to add 2. So with this mapping rule, it might be more helpful because we're going to take our x, which is 4, we're going to times it by -1/2, which would give me -2. -2 plus 2, 0. 3, I'm going to times by -3, -9, -9 plus 2. That's the coordinates of the transformed point. So using a mapping rule is super helpful to keep you organized for the actual math you have to do. So 4 times -1/2 is what? You have to common factor that -2 out in order to see the transformations. That's like the first step in doing it. You can't do it off of this. You can't do it off of that one. You have to common factor out that negative to get that second set of brackets. Because if you do that, then you'll have the wrong transformation. Your y will be right, but your x will be wrong. All right, short lesson today. Short lesson.